So we already see how we use IDE to create a Java program. And throughout this course, we will keep on learning more and more statements and syntax and algorithms on how to create a useful Java program. And basically, this is the whole focus of this course. But in addition to the statement and syntax, there's also this process of programming. You need to clearly define what the program is to do. For example, we want to print out a sentence saying hello world. You need to visualize the program running on the computer, how it will look like. It will be one sentence written on computer monitor. You are literally outputting a statement, a sentence to an output device. Then you will use certain design tools to create a model of the program. Right now, because the hello world is so simple, it's just one statement. You don't see how you can use a design tool. But very soon, we will start talking about how to use design tool. And Eclipse can actually help here too. Then once you have the model, you have the program model, you can check the model for logical error. So this part, these 4 steps are still conceptual process. Once you pass this conceptual process and defined your programming model, you will start coding. You will enter the code and compile it in Eclipse. You will correct any error found during compilation, just like what we did just now in previous session. When we have the error, we go back and based on with the help of the error message itself, we were able to fix the error and recompile it. Then we will run the program with test data. Eventually, we will correct any runtime error found while running the program. And finally, we will validate the result. So this part of entering the code, compile and run and run into errors, is a part of programming process. It's basically every programmer does. No matter how experienced a programmer is, they will always make mistake, and no program will pass in the first time. So when you run your program and run into errors, do not panic. You should have the self-confidence that now you are part of the Java programmers, because running into error is just a part of programming. All you need to do is identify the error and fix that. There will be many different mistakes and errors that you will run into. But as you resolve this issue, go through this course, you will get better and better. And on our side, my side, I will definitely help. I will provide you with simple tasks first and gradually increase the difficulty. But still, it will be within your grasp. And eventually, finally, if you have any questions, ask me and ask your classmates. So this is the programming process. Now, as you can see, if mistakes always happen, there got to be a way to manage those Java programs. This is what software engineering is for. Software engineering encompasses the whole process of crafting computer software. Software engineers perform several tasks in the development of complex software projects, including designing, which is the conceptual part, and writing, which is writing the code. And you test and debug. Debug is basically identify where the error is. So by default, we are saying we will have errors. When we say testing, you never directly go into documenting because you know you will have error. Test will always find some error. Then you will need to debug the error. Once the code is satisfactory, you will document it. Write down what it is used for, how to use it, and then you will do some modifying based on the user feedback and got into maintenance mode. Software engineers will not only write programs. Of course, you need to write code, but you also need to write the following: specifications, which is the design. Why would you design and why would you work on a program? Diagram of screen output. Diagrams representing the program component and flow of data. And the pseudocode, an example of expected input and desired output. So all these may seem unnecessary if you have simple programs, but if you are involved in the commercial product, it will be very hard to understand. After a while of development, it will be hard to check what is undergoing and what is why we need a certain component. These documentations are necessary for checking the system and make sure the development is on course. Software engineers also use special software designed for testing programs. And most commercial software applications are large and complex. Usually a team of programmers develops them. And the requirements are thoroughly analyzed and divided into subtasks that are handled by individual teams and individuals within the team. So as you go through this course, you will see the control structure become more and more complex, and people will have hard time understanding a program easily if they didn't write the code or didn't have outside help. That's why we need to have this software engineer, because you work in a team. You will have your team members reviewing your code. And if you leave the company, you will also need to hand your work to someone else to take over. All this requires a specific way of creating software so that people have a common understanding of how a software is made. This is what software engineering is for. You will learn more of software engineering in following courses. It's not a part of this course, but it will be a part of future courses. So let's talk about procedural programming. Older programming languages were procedural. When we talk about procedural, procedure is a set of programming language statements that together perform a specific task. Procedures typically operate on data items that are separate from the procedure. In a procedure program, the data items are commonly passed from one procedure to another. So like this one, procedure A generate one element and send this to procedure B. In procedural programming, procedures are developed to operate on the program's data. Data in the program tend to be global to the entire program. So procedure A, procedure B, procedure C, they are all part of the program and they can all see the data. The data format, the problem with this approach is that if you change the data format in one procedure, all other procedures has to change. An example is, for example, the car license plate in certain part of the nation is 7-digit or 7 characters. But in some other state, it may be 8-digit. If I create a procedure that handles 3 procedures that only operate on 7-character car license plate, once I go to some state that have 8 characters, all 3 procedures must be changed. That's why when we have object-oriented definition, the concept of object-oriented programming, object-oriented programming is centered on creating objects rather than procedures. They are melding of data and the procedures that manipulate the data. Data in the object are known as attributes. Procedures in the object are known as methods. So you can see this is one object and you have multiple methods. These methods inside this object access this attribute, but these attributes are not exposed to outside. Object-oriented programming combines data and behavior via encapsulation. Data hiding is the ability of an object to hide data from other objects in the program. So only an object method can manipulate the data, its attributes. Other objects have to use the object's method to manipulate the attribute. This is known as a programming interface. We will cover object-oriented programming in our second part of our course. At that time, all these will make more sense.